What are common debugging issues in ML Ensemble pipelines? Imagine building a puzzle with many pieces that need to fit perfectly. Now picture trying to fix that puzzle when some pieces are missing or out of place. That's what debugging an Ensemble machine learning pipeline can feel like. These pipelines combine multiple models to make better predictions, but they come with their own set of tricky problems. One common issue is data pipeline failures. Since Ensemble methods depend on lots of data transformations and feature engineering, any mistake early on can cause the whole system to stumble. For example, if data preprocessing steps like normalizing or encoding are inconsistent, models might not agree on predictions. Even small mismatches in data format or missing data can throw off the entire ensemble. Feature selection and engineering are also frequent troublemakers. If irrelevant or redundant features sneak into the models, they can introduce noise. This might lead to overfitting, where the models perform well on training data but poorly on new data. When different models handle features differently, their predictions can become inconsistent, making it hard to combine their outputs effectively. Debugging here involves checking that feature handling is uniform across all models. API and dependency errors are another common headache. Ensemble pipelines often use multiple libraries or frameworks. If one library updates or deprecates certain functions, it can break the pipeline. For instance, if a data processing library changes how data is shuffled or how models are trained, it can cause unexpected errors. These issues often show up as missing arguments or incompatible data formats. Runtime and environment issues also cause headaches. When pipelines run across different systems or in distributed environments, mismatched software versions or missing dependencies can lead to errors. Debugging these requires replicating the environment locally with sample data to see where things go wrong before running the full pipeline. Model integration and output aggregation errors happen when combining predictions from different models. If the formats don't match or the weighting scheme is off, the final prediction can be wrong. For example, if one model outputs probabilities and another outputs class labels, merging them without proper handling can cause confusion. Debugging involves verifying each model's output and ensuring the aggregation logic is correct. Bias and variance issues can also crop up. If the pipeline is not set up properly, the ensemble might suffer from high bias, meaning it underfits, or high variance, meaning it overfits. Checking model performance on training and validation data helps identify these problems so you can adjust the pipeline accordingly. Finally, monitoring and logging are often overlooked but are essential. Without good logs, it's hard to see where errors happen. Proper logging of each step helps trace issues back to their source, whether it's data, code, or environment. To troubleshoot these issues, you can run individual pipeline steps with small sample data, use logging tools to track errors, or test in a controlled environment. These steps help pinpoint whether the problem is with data, code, environment, or how models are combined. Understanding these common debugging issues in Ensemble pipelines is key to building reliable machine learning systems that work well in real-world applications.